Okay, so when you picture the start of industrial innovation, what usually comes to mind?
Right, probably steam engines, smoky factories.
Yeah, maybe the 18th century. Well, get ready for a bit of a twist today,
Uh-huh.
because we're doing a deep dive into a story that's, well, much older and frankly richer than that common picture.
That's right. Today, our mission is really to uncover the, frankly, astonishing ingenuity of Muslim engineers way back in the Islamic Golden Age.
Specifically the 9th century.
Exactly, ninth century. We're talking about, pioneering work with watermills, amazing use of cranks, and genuinely automated industrial machines. Pretty wild stuff.
It really is. Imagine Baghdad back then, 9th century. The Abbasid Caliphate is booming.
The absolute peak.
And it wasn't just a big city, it was this like intellectual and engineering powerhouse, centuries ahead of what was going on in Europe at the time.
Definitely. A place where these brilliant minds weren't just thinking things up, they were building them,
Mm.
testing, refining.
And right at the center of all this, you had these three brothers.
Yeah, the Banu Musa, Ahmad, Muhammad, and Hassan. Their work is incredibly well documented in this text called the Book of Ingenious Devices.
So for you listening, think of this deep dive as your shortcut. We're going to pull out the key insights.
Exactly how these minds took Greek mechanics, Persian hydraulics, Indian math,
And combined it all.
right, to create these practical working machines,
Yeah.
things that actually influence technology across the East and West later on.
We'll unpack some really surprising facts, show you the lasting impact. Let's just jump right in.
Okay, so the Banu Musa brothers, they weren't just inventors tinkering away. These guys were polymaths,
Meaning,
meaning they excelled in multiple fields, mathematicians, astronomers, and engineers, and they had backing.
from the caliphate.
Yep, supported by the Abbasid Caliphate,
Mhm.
especially through Baghdad's House of Wisdom. Think of it as the empire's, like, main research and translation center. A huge deal.
So, crucial point here. They weren't just copying old Greek texts.
Not at all. That's the key. They were actively innovating. They rigorously built upon that ancient knowledge, really pushing the boundaries of mechanics.
Okay, so what was it about their approach or the principles these machines actually ran on?
Well, around 850 CE, they put together their big work, Kitab al-Hil.
The book of tricks or devices, right?
Exactly. Or ingenious devices. And it's amazing because it has some of the earliest known drawings of automatic machines. What's really striking is how sophisticated the underlying principles were.
Like what specifically?
Things like water pressure, air suction, really clever float valves. And this is a big one, crankshafts.
Ah, the crankshaft.
Yeah, these weren't just ideas, they were fully worked out mechanical systems.
Okay, let's talk about that crankshaft because that feels huge. Here's maybe historical nugget number one for you. The crankshaft, fundamental to almost all modern engines.
It was effectively pioneered by Muslim engineers.
Mm.
The Banu Musa were among the very first to design and actually use cranks and connecting rods together in complex machines.
And the significance of that is
Was massive, right?
hard to overstate. Before this, you're mostly dealing with continuous rotation, like a wheel turning, or simple linear motion.
Right.
The crank and connecting rod system, that was the key. It lets you convert that turning energy, say, from a water wheel.
Into a back and forth motion.
Exactly, reciprocating motion. That's the heart of pistons in steam engines, car engines, you name it. It wasn't just a gadget. It was a core concept that unlocked so much potential for machinery.
That's really incredible. And were these just sort of fancy toys for the elite? Or did they have real-world uses?
Oh, definitely practical applications. That was a huge focus.
Like what? Give us some examples.
Okay, well, they built very accurate water clocks, super important for timing prayers.
Ah, okay. Makes sense.
Fountains that could change their spray patterns automatically based on water pressure changes. Really quite clever.
Wow.
They even designed lamps where the wick would adjust itself automatically as the oil burned down.
No way. Automatic lamps. Yeah. And beyond those sort of personal or civic devices, they engineered complex irrigation machines, things using screw pumps and chain pumps to lift water much more efficiently.
Which would have been huge for agriculture.
Absolutely massive. These weren't just theoretical designs. Farmers, architects, city planners were using these across Syria, Iraq, Egypt, Persia. Widespread adoption.
Okay. And while we're on surprising early tech, windmills, another one that pops up earlier than many people think.
Right. Historical nugget number 2, maybe? Windmills weren't a Banu Musa invention specifically, but they were definitely around in the region. We see evidence of them in eastern Persia as early as the 7th century.
7th century, wow, that's ages before they become common in, say, Holland.
Centuries earlier. These were mostly vertical axis windmills, picture sails made of reeds or clock, spinning around a vertical pole, used for grinding grain, pumping water.
So it really shows this broader culture of mechanical innovation happening.
Exactly. Independent developments, solving local problems with clever engineering, long before similar things appeared in the West.
So what was it then that really set these engineers, like the Banu Musa, apart? Was it just the knowledge they inherited?
The knowledge was crucial, of course, but I think what truly distinguished them was this relentless spirit of experimentation and practicality. They weren't afraid to test things, iterate, improve design.
They weren't just drawing concepts.
No, this is a really critical point.
Yeah.
They weren't satisfied with just theory. The Banu Nusa, for instance, they specifically described designs for machines that could, say, automatically shut off when they were full.
Huh, like a sensor.
Sort of, yeah.
Mm-hmm.
Or machines that maintained a constant water flow using feedback systems. And they used float regulators, these clever little devices with a float that rises with the water level to close a valve.
Like in a modern toilet tank.
Exactly the same principle.
Yeah.
To ensure precise control. They didn't just imagine this stuff. They built it, tested it, and this is key, they documented every part, often with detailed drawings. That's real engineering practice.
And all this practical application, this building and testing, it led somewhere big.
It really did. Here's maybe historical nugget 3. Baghdad itself and nearby cities became major industrial hubs, largely powered by watermills.
Industrial scale in the 9th century.
Absolutely. By the 9th century, watermills were everywhere along the rivers and canals. They weren't just for grinding a bit of grain for the local village.
What else were they doing?
Well, grinding wheat into flour on a massive scale, yes, but also fulling cloth that's pounding woven fabric to thicken and clean it, processing sugarcane, even powering trip hammers for early paper production.
Paper production, that was a big deal then, right?
Huge. Paper was relatively new technology itself, spreading from China. Having mills to help produce it faster and cheaper was vital for administration, scholarship, everything. And what's really cool is the infrastructure link.
How so?
These mills were often strategically placed along extensive canal systems that Abbasid engineers had built or improved. It was integrated. This turned Baghdad and other cities into real centers of production and trade.
Which suggests a society that really valued this kind of innovation.
Definitely. There was whole culture supporting it. The Abbasid court, for instance, actively encouraged and rewarded practical inventions.
What kind of inventions got rewarded?
Things with clear benefits, making food production easier, helping cities grow, keeping accurate time for religious purposes, improving irrigation for agriculture, stuff that made life better or the state run smoother.
So it pushed scholars and engineers to connect science with, like, actual utility.
Precisely. Bridge that gap. And here's another really important piece. Historical nugget 4, maybe. They shared the knowledge.
They didn't keep it secret.
Not in the way we might think of trade secrets today. Muslim engineers generally wrote detailed manuals with diagrams. They explained their methods. They trained students. This wasn't hidden knowledge.
And that's how it spread.
That's a huge part of it. These texts, these manuals, eventually made their way, often through trade and conquest routes, to places like al-Andalus, Muslim Spain, and Sicily.
And from there,
they were translated into Latin. And that translation effort was a direct spark for renewed European interest in mechanics and engineering during the later Middle Ages and Renaissance. The knowledge flowed.
that's an incredible pathway of influence, and the legacy continued within the Islamic world too, right? It didn't just stop with the Banu Musa.
Oh, absolutely not. You see later engineers building directly on their foundations. Probably the most famous is al-Jazari around 1206.
What's he known for?
Incredible stuff. Highly intricate automata-like mechanical peacocks, automated hand-washing devices, sophisticated water clocks, including his famous elephant clock, even designs that some people interpret as early programmable machines.
Oh, wow.
Programmable, using pegs and cams to control sequences, yeah. And later still, in Ottoman Istanbul, you had Taqi el-Din in the 16th century, building complex mechanical clocks with minute and second hands. The tradition continued.
That is just fascinating. And you mentioned something about interactive fountains.
Yes. Another Banu Musa gem, let's call it historical nugget 5. One of their designs was for a fountain that didn't just run constantly. It would activate only when a person walked near it.
How on earth did they do that back then?
It used a really clever system involving air pressure and suction, triggered by the displacement of air or water from a hidden mechanism when someone approached. basically an early interactive machine.
That's mind-blowing for the 9th century.
Absolutely. These were apparently quite popular in royal gardens and public squares in big cities like Samarra and Basra. Imagine walking up to a fountain and having it suddenly spring to life just for you, 1,000 years ago. Pure wonder.
So if we kind of wrap this all up, the Banu Musa brothers, their colleagues, their successors, they weren't just, clever guys making neat gadgets.
No, far from it. They were true industrial thinkers, you could almost say. They really understood that for machines to be valuable, they needed to work reliably, effectively in the real world.
They could work easier, improve cities, manage resources, and, yeah, probably impress the rulers, too.
Sure, patronage was important, but the focus on practical application is undeniable. And if you connect this back to the bigger story of technology,
Yeah.
it gives you this profound insight, right? That long before we get to Watt and the steam engine, long before the factories we usually associate with the Industrial Revolution.
The Muslim world was already deep into experimenting with automation, with sophisticated pressure systems, with crank-driven machinery, real engineering.
Exactly.
Hmm.
Now, these inventions didn't trigger the same kind of industrial age overnight, obviously. The context was different.
Right.
But they absolutely laid down some of the fundamental mechanical groundwork. It's a crucial part of the story that often gets missed.
It really is. And maybe the final thought for you, our listener, to kind of chew on, what does this incredible history tell us about today?
Think about it.
Hmm.
In that era, in Baghdad's House of Wisdom and beyond, knowledge wasn't just hoarded by a few elites in ivory towers.
Right. It was actively shared, written down, taught, and intentionally applied for, well, seemingly the benefit of the wider community, or at least the functioning of the state and cities.
Yeah.
So what does that teach us about the role knowledge plays, or should play, in our society today? How we value it, how we share it, and how we choose to use it. Something to think about.